Good day, students. We're going to look at a solution now to the learning check on page 103, chapter 8. These are problems dealing with angle of elevation, angle of depression, line of sight, using trigonometry, sine, cosine, tan to solve. Okay, so this first one here now we're looking at, I want to talk about line of sight and angle of depression and so on. Okay, so just imagine now, let's say you were looking up in a window of a house. Okay, so let me just draw a quick sketch. Here's your house, and you're along the ground and you're looking up here. Okay, so as you look up to someone, say in a window up here, and this person's in a window up here in your house, the line of sight is the actual line from your eyes up to that person. We call this the line of sight. Okay, and for either person, looking up or looking down. Now the words angle of elevation and angle of depression, okay, I want to talk about those for a second because they are actually the same angle. So if I make a horizontal here right at the line of sight here, and I do the same thing for this person's line of sight, okay, then the angle of elevation and angle of depression are actually the same angle. Okay, here's what I mean by that. This angle right here is called the angle of elevation. It's always along the horizontal, and that's made with the horizontal line and of course the line of sight. So this is called the angle of elevation, that one right there. Now the angle of elevation is made with the horizontal and line of sight. The angle of depression is the same angle. It's this angle here looking down, and these are equal angles because this is also along the horizontal, okay, and the line of sight. So one is called an angle of depression, and again it's along the horizontal line, right, with the line of sight. So this angle here is the angle of depression, this angle is the angle of elevation, and one is just looking down, the other one is looking up, but it's always along the horizontal. Okay, and it's always made between the horizontal and the line of sight. They are truly the same angle, and that's because the horizontals are parallel lines, right? So those angles are equal. So in this particular question, okay, so when we look at this one and we're told the angle of depression, okay, there's the angle of depression right there along the horizontal. And the mistake people make is they put the angle of depression along the vertical. So this is the angle of depression right here, which of course if it was angle of elevation would be the same angle down below looking up, right? The angle of elevation would be this angle right here along the horizontal, but it's, you know, looking when looking up. So this is what we call the angle of elevation. They're actually the same line because the horizontal lines are parallel. Now, so let's just take away all of that. So that's the angle of, don't put it here, okay? Like a mistake people make is they put the 19 degrees right here. That is not an angle of elevation or depression, okay? So don't put it there. So the angle of depression is that angle right here, and that is 19 degrees. Okay? 19 degrees right there. See that? Okay, now let's form the rest of our right triangle by, of course, joining this to this, and we have our right triangle, don't we? Alright, let me redraw that again. Okay, now the right angle is right here. You can see the right angle, I'm sure. Oops. There's a right angle. And let's see what else we know. If the helicopter is flying at a height of 800 meters, so you may have decided to draw the triangle the other way, right? And that's perfectly correct as well. You might have drawn it down here because the altitude is 800 meters above, so the altitude is the perpendicular height. So you may have drawn it this way, which is fine as well, right? So you could have drawn it either way. Now the 19 degrees, of course, that angle would go here as well, because we know angles of depression and angles of elevation are equal, the same angle. I can put the 800 meters here, or I could have put it over here as well. So either triangle doesn't make any difference. Now the question is, you want to know how far the helicopter is from the oil tanker, and that's of course caught right along the line of sight. So we're looking for the hypotenuse, aren't we? Let's call it x. Now again, you have to decide which one are you going to use. Okay, so if I'm using this angle 19 degrees with this side which is opposite and this side here which is a hypotenuse, then you'll have no choice but to use the sine of the angle. Right? So it's the sine of the angle, which is 19 degrees, is the opposite side, which is 800 meters, divided by the hypotenuse, which in this case is the line of sight, or the distance between the helicopter and the oil tanker. And now it's a simple algebraic equation to solve. So put this over 1, cross multiply, it's x times sine of 19 equals 1 times 800, which is 800. Now of course divide each side by the sine of 19 degrees, and of course that isolates the x, doesn't it? 19 degrees, so that cancels with that, and x is equal to 800 over the sine of 19, which turns out to be 2,400. Now does it say nearest meter? Yes, so no decimals. 2,407 meters, and you can check that on your calculator. So that's the solution to the learning check on page 103.